This is PreCalc 11, Chapter 4.7. We're going to be looking at modeling and solving problems with quadratic functions. To solve word problems, you need to convert words into math operations and know formulas. The problem with English is that there are many synonyms and it is impossible to list them all. So, sum, more, increase, total, whole. This generally means add. Difference, less, decrease, change. This means to subtract. Product, expand, scale, of means to multiply. Area. This is a formula you need length times width. Revenue or cost. This is generally price times number of units. Vertical projectile position. So, if you're in meters, this is negative 9.8 t squared in seconds plus vt plus h. If you're in imperial units, we have minus 32 t squared plus vt plus h. And again, t is in seconds, and this would be in feet. And generally, with quadratics, the formula will be the product of two factors. And when you're given a problem, if a drawing is not provided, make a drawing. Here's an example. The sum of two products is 40. Find the maximum product of two numbers. So let's say the first number is x. And the second number is y. The sum is equal to 40. But it's also equal to x plus y. We just write down as much information as possible and see which pieces are useful. From here, we can say that y equals 40 minus x. So we bring the x over to the other side and it becomes negative. Product is x times y. We don't know what that number is. We're just looking for a maximum. So we substitute. We put the y into this y. So x times 40 minus x. Now we can graph this. We have x times 40 minus x. And let's adjust the window. So, looking at this, we see that x should not be less than 0, and x can't be greater than 40. Let's make our scale 5. Our y-min, well, the product and the sum aren't going to be negative, so we'll just set negative 5. And we don't know what the maximum is going to be, so we just test the value. 500 and 100. Again, you can adjust these if things don't turn out. And we graph. Okay, so it does turn out. We see the whole curve, we see a maximum, and we can go ahead and solve this. Second calc, 4 for maximum. Just stay to the left. And to the right of the maximum, and our guess. So our answer is 20 for x, and our maximum is 400. We read the question again. It says find the maximum product of the two numbers. So this is the maximum product. So our answer is And just to reiterate, this is the number. It's number 1, the first number, and this is the maximum product. Here's another example. A farmer wants to maximize the area of his rectangular goat pen using 19 meters of fencing. One side will be built against his barn. Find the dimensions. So let's draw a barn. Now here's our fencing. It's rectangular, and we can label any side as X. So let's label this side as X. Since it's rectangular, this side is also X. We don't have any fencing along here. Our total amount of fencing is 19 meters, and we're taking away 2X. And when we add this all up, we get 19. Side 1 equals side 2 equals X. Side 3 equals 19 minus 2X. The area, we're not told that we need this formula, but you have to understand that when we're looking for area, we need a formula for it. Length times width. So we have X times 19 minus 2X. And we can go ahead and plug this in on the calculator. Clear X 19 minus 2X. We'll leave the window the same for now, and then we'll just graph. That's not very good. It doesn't show up very well. So let's make it less. We'll change this to 10. And we'll change the max to 50. And we'll go up by 10s. Graph. And that looks better. It doesn't look quite the same as this graph, but we should get the same answer. Calculating maximum. Left bound. Enter. Right bound. Enter. Enter. And we get the same value. It's off by a small decimal place, but it's the same value. Again, we need to go back to the question and look for what it's asking. It says find the dimensions. So side 1 equals side 2 equals 4.75. Okay, this gives us the area. It's not asking for the area, so we just concern ourselves with the dimensions. Side 3, we have 19 minus 2 times 4.75, and we get 9.5. And these are in meters. Don't forget to add your units or you'll lose some part marks. Last example. A donut shop sells 5,000 donuts per day for 75 cents each. For every 5-cent increase, they lose 160 donuts in sales. What price will maximize revenue? And we need to round the price to the nearest nickel. How many donuts will be sold? Okay, so we're answering 2 questions here. So we have revenue equals price times units. I'm going to just change the color here. So I'm going to circle things that involve price. Here we have price, and here we have price. Let's look at units. Here we have units, and here we have units. Okay, so we have price. So this is going to be our X. Now we're going to deal with units. We have 5,000 donuts if they sell it at 75 cents. Now for every increase of 5 cents, they lose 160 donuts. So this is 160 times X minus our original price, which is 75 cents. And they lose 160 for every 5 cents. And there's our formula. And this piece is considered our increase in price. Because every cent above 75 cents is our increase. Okay, so we have a formula. Now we can graph this. We have x times 5,000 minus 160 times x minus 0.75, and then we need to divide by 0.05. We have two left brackets, we have one right bracket, so we need another right bracket. And we graph. Okay, so our window doesn't work for this. We need to increase things. We have to look at what a reasonable price for a donut's going to be, and it's certainly not going to be $10. So let's make it a $3 maximum for the donut as a guess. And the donut sales should be over 5,000 because we have 5,000 times 75 cents. So we'll start off with 5,000. And our Y scale is going to be 1,000. And graph. Okay, that was a pretty good estimate. We can now look for the maximum. And we're to the left of the maximum. Now we need to be to the right. And enter and enter. Okay, so it tells us what the maximum is here. It's the same value. But we need to round it to a nickel. We need to test both $1.15 and $1.20. We need to check the rounding on both sides. So we're going to test $1.15 and $1.20. And the quick way to do this is to go to your calculator and trace. We're just going to enter $1.15. And this gives us 4,278 in revenue. And we'll trace some more and we'll put in $1.20. And we get 42.72. So this gives us our maximum. We need to do one last check. We need to take 4278 and divide this by $1.15. This gives us 3,720 donuts. So we need to answer the question, what price will maximize the revenue? And we'll just write $1.15 will maximize revenue. And the second question, how many donuts will be sold? 3,720 donuts will be sold. So read through the problem, create your equation, use your calculator, and read the question again to make sure what questions you're actually answering. And that completes this lesson.